For vertex embeddings, there are techniques coming from natural language processing, which we have used to come from a vertex environment to a vector representation, which is designed such that two vertices with similar environments, similar but not identical, will in vector space be close to each other. And that's sort of the whole idea behind this, finding similarities but things which are not identical. The way this works is you essentially take your little graph, like the demo graph I've got here. You do random walks following, traversing the graph, like you have vertex 1, 2, 4, 8, and then 1, 2, 3, 4, whatever. You essentially do all of these random walks. When you consider every vertex as a word in a sentence, and every path as a sentence, then you can use techniques from natural language processing, like word2vec, to convert that into a vector. And then you end up with a vector which is representing your original graph in such a way that if there was a pattern which is kind of similar to what you have around vertex 4 here, elsewhere in the graph, these two things, these two vertices would have similar vectors. As I said, similar but not the same. How are customers using this? I thought, because there's a fair amount of attendees here in the audience, also coming from an RDF background, I thought I'd give you an example where we are combining RDF knowledge graphs with property graphs, because we can put a view on top of the RDF graph to do graph traversals and like graph machine learning and stuff. We've been working with a customer in Asia in the area of agricultural research. What they do is they are trying to figure out, on the basis of the pedigree of a plant, in this case a rice plant, what the properties of the next generation will be, because they are, of course, looking for new variants which have better characteristics, whether it be a higher yield or better disease resistance and so forth. They have represented all of their plants with their pedigree and their properties as an RDF-based graph. And then they created a view on top of it and ran deep walk to compute a vertex embedding for every plant in order to be able to predict the next generation of this specific variety.